Welcome back to 1200 plus PYQ series of CSIR NET examination. This question was asked in NET December 2014. The question says that consider the four process 1, that is proton converting to neutron plus a positron plus a neutrino, right? Second process lambda 0 converting to proton plus positron plus neutrino. Then third process pi plus converting to E plus a neutrino, that is pi plus meson converting to positron plus neutrino. And the last process, that is pi 0 meson converting to 2 gamma photons, that is gamma plus gamma. Okay, now which of the above is or are forbidden for free particles? Means for free particle, which of the above reaction are forbidden? Your options are option 2, option 3 and 4, option 1 and 4, and last this as in your screen, right? So now let us solve it. So the first reaction is, that is proton converting to neutron plus positron plus neutrino of electron origin. Okay, since the particle is free, this reaction is forbidden. Okay, since the particle is free, it is given in the question, this reaction is forbidden because it is a nuclear reaction and it is possible inside the nucleus only, so that the energy and momentum will be conserved. So a free proton can never decay into neutron. This is possible only when this proton is a part of nucleus. Okay, when this is part of nucleus, means inside the nucleus. So here energy and momentum will not be conserved because the particle is given here to be free. Okay, so first reaction is not possible. Okay, now let us check the second reaction. The second reaction is lambda 0 converting to proton plus a positron plus a neutrino of electron origin. Okay, so here let us first check charge. Okay, charge Q. Lambda 0 is a neutral particle, so its charge is 0. Proton is a positively charged particle, positron is a positively charged particle, and here that is neutrino is a neutral, that is it doesn't have any charge. So you can see that the LHS has charge is equal to 0, but the RHS has charge is equals to 1 plus 1, that is equal to 2. So a left hand side charge is not equal to right hand side charge, hence our charge is not conserved here. Okay, our charge is not conserved here. So we can say that since there is a violation of charge conservation, so this reaction is also forbidden. So first reaction is a forbidden reaction, second reaction is also a forbidden reaction. So now let us check the other two reaction. Okay, this is the third reaction. This reaction says that a pi plus meson is getting converted to positron and neutrino of electron origin. Okay, so now let us first check the charge. Now pi plus has charge of plus 1, right? So its charge is plus 1. Positron, that is E plus, has charge of plus 1. Neutrino is neutral, so its charge is 0. So LHS charge is plus 1 and RHS charge is plus 1. Hence the charge is conserved, that is delta Q. Okay, we represent delta Q as the difference in charge of LHS and RHS. Since both sides charge is same, so our charge is conserved, that is delta Q is equal to 0. Now let us check the lepton number. Okay, you must know the lepton number, baryon number, iso, spin, and various other quantum numbers for various particles. Better if you search in the net that is the quantum numbers for nuclear particles, then you can get a lot much of information that what are the lepton number for pion, what are the lepton number for positron, what are the lepton number for muons, and other particles also you can just easily find. Okay, so lepton number is defined for lepton only. By lepton we mean that electron, okay, electron, positron, muon, tauon, etc. For other particle the lepton number is 0. So pi plus, for pi plus this lepton number is 0. For E plus, that is positron, the lepton number is -1, because for electron this lepton number is 1, and positron, since it is an antiparticle, its lepton number is equals to -1, right? So for leptons the lepton number is 1, for antileptons, okay, or antiparticles, this lepton number is -1. Okay, now nu E, that is neutrino of electron origin, its lepton number is also 1. Okay, remember that for nu E lepton number equal to 1. Okay, right? Okay, just let me check it. Okay, right. For nu E lepton number is equal to 1 if we consider its antiparticle, that is anti-neutrino, that is nu E bar, its lepton number will become -1. Remember this thing, that for nu E, okay, means anti-neutrino, nu E bar means anti-neutrino, the lepton number is -1, and nu E, that is neutrino, the lepton number is equals to +1. Okay, now let us solve this question further. So here you can observe that this lepton number, okay, this lepton number, that is L, is 0 for pi plus, -1 for E plus, and for 1 for nu E. Hence the lepton number LHS is 0, RHS is -1 plus 1, that comes out to be 0, right? So hence lepton number is equals to 0, that is change in lepton number is equals to 0. Hence lepton number is conserved, charge is also conserved in this reaction. Now let us check for the isospin. Okay, isospin is also another quantum number, right? For pi plus the isospin is +1, and for electron, positron, neutrino, the isospin is 0. Hence we can say that LHS side isospin is +1, RHS side isospin is 0. So since charge is getting conserved, L is getting conserved, that is lepton number, so this reaction is an allowed reaction. But you can observe that here isospin of LHS is +1, RHS is 0. So this reaction is a weak reaction, right? Any reaction in which isospin is not conserved is a weak reaction, or it is a weak interaction. Okay, so hence this reaction is an allowed reaction. This is allowed reaction by a weak interaction. Now let us check the last reaction. Okay, in the last reaction it is given that pi 0, okay, pi 0 meson means neutral pion is getting converted to 2 gamma photons, that is gamma plus gamma. Okay, so this reaction basically involves gamma photons. Okay, gamma photons is involved here, hence this is an allowed reaction via electromagnetic interaction. So this reaction, that is pi 0 meson is getting converted to gamma plus gamma photon, is an example of electromagnetic interaction, hence this is allowed. So what we have found, that the third reaction is allowed, the fourth reaction is allowed, the second reaction is not allowed, the first reaction is also not allowed. So let us see which option is correct. So what we got, 1 and 2, these are not allowed. 3 and 4, these are allowed. So let us check the option. The option is, okay, the first the question says which of the above is or are forbidden, means 1 and 2 are forbidden. So option number D, that is 1 and 2 are forbidden, is the correct option. For more videos, please subscribe to my channel Researcher on Physics, and for more such PYQ solutions, please check this playlist. Thank you. Have a nice day.